welcome to our panel discussion. We have, about an hour? A little bit more? Hour and a half? Great. And we're going to I'm going to shoot for about 45 minutes of questions from me, and then we'll turn it around to the audience. And please keep me honest there. We'll start with some intros. So Hursh, we've known each other for a while. I'm excited to be up here with you. And you are co-founder of the browser company, makers of Dia and Arc, which are both great browsers. This is embarrassing. I finally tried Dia recently, and it's really good.
Nice.
I'm a huge Arc fan for a long time.
Appreciate having you on the new stuff. Everybody else try Dia, please.
And Kevin, we met more recently, a founding engineer at Warp, the terminal that is a really, really good terminal, and also has some agentic coding capabilities that we'll be hearing more about soon.
Yeah, definitely. Also try out Warp.
And Mark is the head of technology at Clay, and has been doing that since the company was like 10 people in a loft in Williamsburg. And look where we're at now. And we'll share more soon.
Sounds good.
So to go into, actually, before we intro ourselves a little bit more, I'm curious to learn a little bit more about the audience. So who here is a software engineer? Yeah, so that's basically everybody from my read. Who here identifies in some, who here has built a production app using AI, like where AI was in the app, right? Like you're not just coding with AI, like AI is in your app. This is an agentic application. And keep your hand up if you would consider it an agentic application that you built, agentic software in some way. Okay, I think that's like probably at least 70, 80%. And raise your hand if you consider yourself like an AI product engineer or agentic product engineer. Okay, so it's more like 50-50, 40%, something like that. Cool. So I would love to hear, kind of as by way of introduction, I think probably everybody's familiar with our products here at a high level, but I would love to hear the number one most used agentic feature or product within what your company offers.
Yeah, so Dia is an AI browser. There's a whole AI browser war going on right now. It's a little strange. We have a lot more agentic features coming, but actually the main agentic feature in Dia is Dia's chat itself. And so it's a little bit of a strange question for us. That's the most used feature. We have more coming soon.
Yeah, so for Warp, Warp's mission is always being helping developers maximize their productivity. So all of you guys are our target customer. And when we started as a terminal. And recently we pivoted into building something called Agentic Development Environment. I know it's quite a mouthful, but what it really is you can think of it as a terminal-based computer use. So we use terminal as kind of the platform for agents to interact with your computer in all sorts of environments. And it's not limited by, like if you're using IDE, it's kind of limited by your project. In Warp, you can really do anything from deploying your remote server, debugging your prod environment, or even doing multi-code-based refactors. If you're a developer, try it out.
Yeah, in Clay, we have an AI internet researcher called Claygent, and it has billions of runs, so that's definitely by far our most used agentic thing in the product, and actually one of the most used things in the product at all. And yeah, we started developing it a couple years ago, and it's gained more and more capabilities as models have gotten better. So yeah, you should check it out as well.
Awesome. And just while we're setting things, like I'm curious, like, how do you guys think about an agentic product engineer? Is that something that blends in with the rest of your org? Is it a distinct job title? How do you hire for it? And what does onboarding look like? Like, is if you hire like a AI engineer who's going to like actually build a LLM, and they had never done that before, you would probably take a long time training them. What does training look like for folks who haven't done that before?
Yeah, we've had some evolution here as we've built more AI features. I think until recently, we really had AI engineers and product engineers as kind of separate, and product engineers would focus on sort of the UI and the product experience, and AI engineers would focus on sort of the prompting and the evals and hill climbing and all that stuff. I think we're finding that they're really kind of the same thing. Like it's kind of the new full stack. You have to, if you're building new products, you kind of got to know about how context windows work and how prompting works, especially because for new features, we're more and more starting prompt first. Like that's kind of the hardest part. So you got to start with the prompt, see if it's viable, and then build the UI after it. So we're finding increasingly that it's kind of the same profile. Like product engineers now need to be AI engineers, and we're thinking about sort of merging the JDs a little bit more into like, this is just the new product engineer.
Well, I very much agree with what Hursh says. To me, really, agentic product engineering is fundamentally product engineering. I think a common mistake I've seen a lot of people make is, looking at a human workflow and say like, let's just swap it with the agent. That would just work out just fine. And what we discover in practice is agents a very powerful tool, but it cannot really replace humans. And at Warp, what we really believe in is agents should be always keeping track by the human. Human needs to stay in the loop to monitor agent as it progress and perform all sorts of checks. So yeah, a common example is we are looking into this on-call process and how we could optimize it. And if you look at the whole process as a whole, there's so many different problems you could think about. And an actual like engineering pain point here will be, there's so many prot logs that you could go through, and it's very hard to find the culprit. So that's something that actually plays into an agent's strengths, because it can search through all these kind of needle in the haystack problem and can utilize all the different contexts it does to find the right set of solutions for that problem. And it can then report back to the engineer to save them hundreds of time, rather than letting the agent to run like endlessly in 10, 15 hours trying to find and address the problem as a whole.
Yeah, I mean, I would just echo what the other two said. I think product engineering is sort of at the core of AI product engineering. And so a lot of those skills translate. And at Clay, everybody's basically a full stack engineer, those who are working on agentic things and those who aren't. And so a lot of those same skills, iterate quickly, get feedback quickly from customers, et cetera. All of those are sort of the same core skill set. You have some different terminology or different technologies that you're working with sort of day to day. But those are easy to sort of pick up, especially now that it's such like a hot sort of thing and people are fairly familiar with it coming in. So yeah, that's sort of how we think about it.
Cool. When people take people building agentic applications, there's it's so early. There's a lot of experimentation. That most of the development effort these days is going towards kind of like prototypes or things that don't hit scale. Once you hit something that really does hit, that starts to go from 5 people using it to 5,000 or 50,000 people using it, compared to what we're used to with scaling a traditional application, what do people need to keep in mind when scaling an agentic application?
Yeah, so at Warp, one thing we find is it's really important to keep the main part of your agentic strategy very experimentable with actual prod traffic. Because the model and underlying technology evolves so fast. Like every few months, we're gonna have a new model come out. There's gonna be a new kind of tool use that's come out. And if you don't have an infra that supports quickly iterating through your prod data, you might run into a lot of like actual production issues where you decide to fully deploy it to 100% of the traffic. So one key characteristics that we build into our product is our server is fully stateless across different agent requests. So the trade-off here is obviously like the client will have to round trip their conversation data and a lot of metadata related to the request every single time. But the key benefit here is then we could easily swap out a part of the strategy and replace it with a new one with minimum like state migration that we need to worry about. So our engineer can go from 10 minutes to building a server within this new strategy, push out to 5% of traffic, collect the result, and come back and say, okay, this is a viable strategy. We should keep iterating on it. Yeah, I think that's one thing that's very, very different compared to when you're doing like in general product development without AI.
One thing we found is as you scale the application, the edge cases really start to grow, especially with a non-deterministic application. Like you're like, okay, it mostly works for our team, but then suddenly you go to one more order of magnitude, and the random states people are in, how the AI responds, you get so many more of these edge cases. And so I would echo that a lot of it is investment in tooling for us to figure out, okay, as we see these edge cases, how do we capture them? How do we convert them into evals? And how do we hill climb on our quality or our prompts or fine tune or whatever to make sure that our AI systems manage those edge cases as the traffic grows?
Yeah, I would agree there. Definitely like observability is important, as with any sort of like large scale system. Other things that come to mind that we've sort of dealt with a lot, rate limiting is a big thing. Tokens per minute or tokens per second is not really something that a lot of rate limiting frameworks have dealt with in the past. It's usually sort of like total number of concurrent requests or total number of requests per second or something like that. But having variable cost requests is not something that a lot of rate limiting frameworks support. So that's something we invested a lot of time in. There's also an expectation from the user around being able to stream the results back because these requests take so long. So that's another thing, like as you scale your infrastructure, you need to take into account the streaming infrastructure that you'll need to support streaming the answers back to the users as well. So I would add those on as well. So.
Ooh, that reminded me, another one we've had to invest in is counter abuse, actually, and people hitting our endpoints to steal tokens. And so having more and more sophisticated ways to track, okay, like this is coming from, this geolocation or IP or this kind of thing, and then, blocking those specific ones as it shows up.
Yeah, that's very interesting because we got into a very similar situation very recently. I'm not sure if you guys seen the report coming out from Cloud and Factory about how they use like AI orchestrated fraud measures to basically probe your system and figuring out the whole like the sign up logging flow and figuring out how you can basically reverse engineering entire like request API and build a API framework for that and just connect it with Open Router. Then your service become a free token farm for them. And we had to evolve a lot of our infrastructure to actually adjust that. And it was a tough battle. Like they even found some critical bugs in our third-party anti-fraud provider. They did a whole DDoS on our email sign-up endpoint. And yeah, it's crazy out there.
Yeah. Every 6 months, you get a SEV that costs you like $100,000 because somebody rang up your bill.
Okay, maybe this is a naive question, but like, what do people steal tokens for? Is it like obvious if you like read the traffic, like, they're writing mail fraud again? Like what?
I think a lot of them are like using the AI to orchestrate more attacks for like other AIs. That's one thing we found. Also, I think the framework they support like doesn't support using the kind of tool calls we use. So they usually inject a very large chunk of text as instructions to not use any of the tools that natively embedded into the system prompt. I also kind of just think they should sell it as a token for like other people, so you can just basically get free cloud usage. I'm also curious though, so if anyone knows the answer, let me know. This is a top unsolved mystery for me this year.
Fun. Okay, shifting gears a little bit. When one of the hard things is scaling and so on. Another hard thing is going to kind of go back to the prototyping and figuring out what the right thing to build is, right? And I'm curious, like when you're trying to figure out the right use case, the right user story, the right user problem or pain to solve, how do you go about discovering or collecting those?
Yeah, this has been a journey for us. I think this is sort of the biggest risk with agentic product engineering is you will build something nobody uses and nobody cares about. Like, I think that is probably the biggest issue. And you're seeing that in the market too. There's not a lot of AI companies that have real product market fit. And so this has been a journey for us. The initial version of Dia had this like the most obvious stuff. It has a chat bar, and the chat bar you can like create calendar invites and search Slack and do all of this kind of stuff. And just people will use it, but you have to build a habit around it, and it just doesn't have that much usage. And so our understanding of what is important in a browser, in an agentic browser, has changed because of that. Two things, I think. One, our philosophy around product building has changed. AI products from sort of an LLM in a loop that you chat with, to much more the system that can perceive and understand and build context about you, and then proactively suggest things, and then go off and figure out the right capabilities to get that task done, and keep you in the loop alongside. And so it's much more of this environment that just gets to know you and can do stuff on your behalf. And a lot of the sort of the tactical stuff has come from very tight prototyping. So a lot of just like trying prompts, trying stuff, seeing if it feels good. Do we use it on a daily basis before we get to evals and hill climbing and productionizing and all of that stuff? We just got to try a lot of stuff. And that's sort of typical product engineering generally. But finding utility is definitely a big challenge.
Yeah, for Warp, we kind of get away with this one because we are the user of our own product. We are all AI product engineers and try really hard to build something that we can use ourselves. It's basically the answer. It's very funny because at first there was basically no usage in our agent product when we first built it. The prompt was very bad, and one day our CEO just go on like, just went on this spree with our AI system and start dogfooding it for like 7 hours and post 20 like threads about all the feedback. And yeah, that's ever since then, that's what we believe, like how we should iterate and discover these use cases, is to really make sure like if we want to build the best tool out there for the developers, it needs to work for ourselves. And now every time the staging comes down, you'll just see immediately in general, like, why is it down? Like, I cannot use Warp. And I think that's the right way of building towards the right set of use cases.
Yeah, I would agree there. I think for us, like, iterating quickly, and also I think observing what users are doing. Obviously, if you don't have any users, then that's a little bit of a chicken and egg problem. But for us, even before we had Clayagent, we did have a sort of GPT-3 enrichment in Clay, and we sort of noticed that people were kind of chaining GPT-3 enrichments with like Google searches, and then piping that back into a GPT-3 query, and kind of going and kind of unrolling like what now today we know as an agent loop. And we were like, well, what if we, and the React paper had just come out sort of around this time frame, so we were like, what if we just did that like in a single column in Clay? And so we were sort of just watching what our users were doing and kind of responded to that. And after we built Clayagent initially, we would look at the prompts that were flowing through our system that people were trying to use it for, and like things that worked and didn't work well. And so we would sort of like adjust things. And so we were just like very closely observing what was working for users and what wasn't working for users, and kind of like feeding that back into the system. So that would be my greatest advice, I would say. So
yeah, let's go a little deeper there. Like, there's dog fooding at one end of the spectrum. There is sort of like observability of a large system at the other end of the spectrum. And then in between you have, over the shoulder user research, right? You have talking to friends who use your product, or other sorts of secondhand sorts of information, and everything in between. And then, of course, you also have sort of synthetic benchmarks and evals that you build to try to be able to do something close to test-driven development with a non-deterministic environment, which is obviously really tricky, especially when, not just getting to what is the right rough area to build in, but really like get to, okay, this is actually going from good to great, and then keeping it great as you develop. What are you seeing work best there? Like, is it just a case of keep dog fooding and you're good? Or how do you find, evals in production versus development CI?
I'll start by just taking a lot of benchmark out of the picture. What we found is, Sweetbench is hugely popular around a lot of the coding agents, but if you look a little bit deeper into what the Sweetbench is testing agent to do, it's usually pretty stupid. It's like saying like, hey, this is the problem. Here is exactly where I observe the problem to be at this part of the code and this line. Go and fix it. And there's going to be a ton of issue with like just model leaking knowledge because it has been trained largely on part of these problems. So they would just, if you go into the agent tray, sometimes they'll say, aha, I remember this. I will just build this to fix it. So I was like, yeah, of course, you saying the answer, you cheated. And what we also seeing is a lot of times across different agent runs of the benchmark, you get wildly different results. Like we're not even talking about 1 to 2% error margin. It's like 5% swings in terms of the result accuracy. That's why a lot of the Cloud and OpenAI, when they publish the result, they say like best of 10, best of 20, which is crazy if you think about like the scale of how many costs that went into running these benchmarks to just show that it's good. So I would say like evals are definitely important, but it's very important to keep, maybe it's fine to start with some of the SUI bench evals or some of the evals they provide. But it's really important to like focus on your use case and yeah, kind of as Mark says, like use different source to populate your eval either through online monitoring and observing the use cases and understanding what are the critical use cases for your app and like gradually build up a good enough eval set that can give you quantitative insights into how your agent is performing.
Yeah, and just to sort of add on there, in some of our interactions with OpenAI, some of the people that we've spoken with there, they think the future is that of how good your agent can be is the private eval sets that companies will develop. So that will be their like core IP, is the evals on which they sort of like train and evaluate their agents, not the sort of like agent logic itself necessarily. So, which is kind of an interesting sort of perspective. I don't know, but yeah.
We have a very specific take here. Your question had two parts to it. One is like, how do you figure out what's useful? And the second is, how do you keep it stable in production? We definitely do not start with evals. I think we have learned that the hard way. It's just you have to explore via vibes and try to build something that will actually be useful and you genuinely find it useful after day 1 and day 2 and day 3. I think our benchmark is usually trying to get to about 75, 80% quality off just vibes. If we can get to 80% quality off to just like a few prompt iterations and playing with the product, then we know we can add evals and properly hill climb and get to like 98, 99% quality. So 80% quality is usually like B minus quality is usually our benchmark for just getting the product out, prompting, trying a bunch of models. And then if it's useful in that world, then we will go into a productionization mode of like, okay, write proper evals, hill climb on them, make sure you get all the edge cases, and then ship.
Will you put it in, when do you put it in front of users for the first time? Like in a private beta or something like that?
Vibes. Yeah. You want to like get in front of users, get them to use it. And like, they should be like, oh, this is like useful 1/5 of the time, and that's great. Cause then you can get it to 2/5 or 3/5 or 4/5 with hill climbing. And also of course, like latency and cost do not matter. Cause you can always, once you have the evals, you can distill, and figure out sort of ways to get it to be faster or cheaper. But you really want like biggest model purely on vibes, at least we've found, B level quality, and then you can do all the stuff to ship it later.
Yeah, I'll say with private beta, it's very, very important to keep like a strong community of people that just deeply in love with your product. What we find super useful is we have this preview program when we just identify like the top users of our product and just recruit them into this preview build that's built every week. And sometimes we ship some of the like shittiest stuff on there, honestly, just like purely for experimentation. But a lot of times we discover like very key feedback and use stories from these preview communities because they are spending like easily 8-9 hours into our product every day. They understand what are the core use cases we're focusing on, and they can really provide like real-time feedback within 10 minutes. We're out there like, oh, this is great, or like this is bad, and we know whether we want to prioritize these.
What's your most underrated model?
Oh, we use a lot of Flash. We love Gemini Flash. It's so cheap and so fast and fairly smart for that model category, like way better than Mini, GPT Mini or Nano. So highly recommend trying it out for most production workloads.
I mean, we use a bunch of models. And also in our product, you can select the model for most of the features that are powered by a model. We don't really have like a favorite model, I would say. We did find that, at least in our sort of Clagent Navigator model that we built, which is actually a mishmash of a bunch of different agents and sub-agents underneath, that the Anthropic models worked quite well for sort of computer use. And we weren't able to really get the GPT models of the time. I'm not sure if we've reevaluated that since then, but yeah. So, yeah.
Yeah, I was saying Warp, we don't really have a favorite model as well. I would say one thing we do is we do a lot of model routing, which is very important for our use case because we build a generic agent. So a user can come in from a very easy task like, hey, how do I do this in Rust to like, how do I build this whole feature end to end and I expect to work at X certain way. And a key way we ensure that we keep our product quality bar high while not cost user tons and tons of credit is to make sure we classify it based on complexity. Like a simple Q&A can go to even GPT-4o and it does a really, really good job at these versus a complex question will like route it to, I don't know, Cloud Opus 4.5 to think about and come up with a plan. And then we hand it off to basically non-reasoning models. And we observe this way of doing model routing actually significantly increase our overall product quality when dealing with these different array of task complexities.
Can I ask a question?
Yeah.
You guys both have really interesting products in that you have model switchers in there. We don't. And so what are some of the complexities of that? Like, are your prompts really tuned for different models, or you just kind of use the same prompt for different, even if there's a model switcher?
Most of the prompts that are flowing through our product are user provided. Yeah. And so they can kind of pick whatever they want there and what seems to work best for them or fits their sort of like cost quality curve that they're looking for. For stuff that they don't have control over the models for, yeah, we sort of like tie the models to the prompts. So yeah.
Yeah, for us, we are a little bit of a different story because we define our own system prompt. And honestly, like each model has their very different personalities, I'll say. So it's very necessary to have different system prompt for each model. I don't know if you guys remember like when Cloud Sonnet 3.7 first come out, and it's literally 50-50. Like 50% of people say like it's the best model I ever used. The other 50% is just stuck in the loop doing the same thing over and over again. And we have to heavily prompt the Cloud Sonnet 3.7's behavior to avoid these repeated tool calls and avoid thinking too much. Sometimes you ask like, hey, what's the date today? He was like, oh, okay, let me query the different system data to make sure I understand what data is. And so I would just be like, okay, chill. Like you can just put out the date, right? So yeah. So different models behave very, very differently.
Yeah, we've observed that with 3.7 as well, actually. That's a good point. 3.7 is very expensive too, more expensive than a lot of the other Sonnet models. So, and it did, for Clagent in particular, it loved to call tools just over and over. It would have the answer, but it would be like, all right, I'm going to verify this some more. So it would call more and more tools, and it would use way, way more tokens than other similar models for the Clagent sort of like core loop. So we did have to actually add some custom logic to say like, hey, if you have the answer, like just return the answer. So yeah.
Related to that, I'm really curious, especially in the sort of like multi-agent use case. How have you found it? You know, what have you learned about how to pass tools most effectively, or how to provide tools to agents most effectively? Whether that's through MCP, whether that's through like a CLI, or just giving a code execution environment, or sort of the traditional tool calls in the API.
For us, we actually Clagent was created before tool calling was a thing. But we did rewrite it eventually to use sort of like the Vercel AI SDK. So we just use those tool calls that's built into that SDK. It does support MCP as well. So that's sort of like a separate kind of thing that it can also call. But yeah, we just use those like standard tool calling conventions or whatever.
Yeah, for us, we just mostly do standard tool calls because we observe they have the best adhesion to our actual like input-output format. Probably because the model providers like heavily fine-tune on these ones. Also, like a lot of tool calls support streaming, so that's just a pure improvement on the user experience. The problem with MCP is we're still heavily optimizing it, but a lot of times when you have a lot of MCP server provided, it becomes a really like hefty token usage because you just have to list out all the MCPs, provide context for it, just to expose that these are how to use these MCP servers. So yeah, we have been not investing as heavily into MCP tool calls, but we are optimizing that heavily right now.
And what about like the way that you prompt around the tools? Especially like if you're passing it to multiple agents, is that something where you don't have to customize per model?
I will say it's pretty straightforward. Like OpenAI and Anthropic offer very similar APIs for passing tool calls. So yeah, we don't worry about that too much.
Yeah, I don't think we worry about that a lot either.
We do have some complexity just because Dia has a lot of tools and interacts with a lot of websites. A few interesting things we found: we do have to prompt tool instructions both in the system prompt and in the tool instructions sometimes. And then the second thing is often we need to give specific instructions for combinations of tools and how to use them properly, especially because none of these tools are in the training data. So like they're all specific to Dia. So we do have like actually a bunch of logic where first Dia determines sort of the tools it needs to use, and then based on that has different combinations of prompts it puts into the system prompt and how to use these guys together. We've built systems on top of that to try to like manage that complexity over time and have classifiers that determine sort of which combinations of tools and prompts to inject. But if anybody has suggestions on a better way to handle this, we're open.
On that note, I'd love to turn it around to the audience for questions or suggestions. Yeah.
Hey, super interesting panel. I'm sort of curious, you guys talked a bit about how a lot of AI tools, they're like, oh, it's like a chat, right? But with chat, there's this interesting discoverability issue where people have to find what exactly works and what doesn't, and then they get burned on like something that didn't work. So like all this stuff, and I think that's Hursh, you kind of mentioned that like, oh, you're moving more into proactive discovery, etc. So can you talk to the complexity of just discoverability of the users?
Yeah, I mean, chat has so many problems. One is you have to know that you can ask things in it. Number two is like AI has this sort of like jagged capability problem of like you kind of don't know what it'll be able to do well and not. And so you have both this blank page problem with chat. You don't know what to type in, but you also don't know what will, as you said, like actually do well. So the way I think we've realized we can get around that as a browser is we have so much context about you. And so really using that context to pop in at the right times to suggest things. This changes the problem. It's also another hard problem is how do you take a massive amount of context and build a recommendation system for various different types of features, and that is generative and can generate great candidates and then be able to suggest them at the right times. So that's its own ML problem. But we just don't think there's any getting around the blank page problem with chat if we really want strong product market fit, which I think a lot of these AI sort of products don't quite have yet.
Yeah, I'll just quickly add on to that. I heavily agree. I think now we have kind of get over the hurdle with people perceiving us purely as a terminal and more as like agentic product. But early on, people don't even know they could like type into the input box and just ask agent in natural language. And we have to do two things. One is to kind of do like passive suggestions instead of actively like asking user, like putting all the burden on the user to type out the full query. And this is done with a bunch of different triggers. So like, for example, we actively detect if you run into a compiler error, we think this is a good fit for triggering an agent. And that's when we suggest to users, and we immediately see like better adoption of our AI rate because people see like, oh, hey, this is something I can do with your app instead of have that initial like activation energy to type out the full prompt. Another thing we invest in is to have like pretty much a seamless incorporation into our terminal experience and agent experience. We believe that's very important because you can easily switch between these two flows, and to like minimize the friction of you entering a natural language query, we actually build a local classifier, so like easily tell between, is this asking for an agent or is this meant to send to a terminal? And that has also helped us a ton in terms of just removing any friction for you to like type in a query for the agent.
When you think about product engineering before agents, a word that would come up a lot is taste. And as builders and creators, we're always using products, and we're a little snobby about them. And we build our taste by using the product. So you kind of get a sense of what feels right. But I guess my question is, how does one build taste when building agents? Like, have you seen your people on your team or yourself do it really well? Because in some sense, like, you can't be inspired by a UI feature like in the same way when you're building with an agent, because there's a lot of agentic work is in the back end. So it's like, I really want to peel behind the curtain to see like the agent trace on Dia, but obviously I can't. So I'm just curious, like, as a builder, how do you go about building taste, and who's done it successfully and how?
To repeat the question, or to summarize the question, for those in the back, product engineering, it's all about taste historically. How do you bring that in this world?
I love this question. As a company, we're very design driven and very like product taste driven rather than purely metrics. And so a lot of our quest over the last year and a half has been like, how do we distill that product opinion and taste into this new world? And what does that feel like actually? And I think some of it is just, it's still product engineering, it's still figuring out, does this provide utility? For us, it's really important, does this make the user feel good when they're using it? What's the feeling they have in their body when this thing does what it's supposed to and like actually predicts something for you or does something magical? So it's still the overall same structure, but it is a little bit of a different feeling, like I think in a great UI feature, it may be the animations or the sparkles, but I think with AI, it's much more like a whoa, that it just did it, or like, how did it know that? Or it's a slightly different feel, but I think it's still product engineering. It's still taste on like, what do we want the user to experience? What is the ideal end goal? And then working backwards to first de-risk the prompting. Like, is that even possible with the current models and the context we have, like to get to the B minus level quality? And then there's the UI experience on like, okay, if it's not possible, if it's a C minus, then how do we build a UI experience around that where C minus is okay? Like if you think of the original GitHub Copilot, like that was like a D at best, those recommendations. But because you were just typing and you don't have to do anything except press tab when it's a good one, that's totally fine. And so there's this sort of secondary thing of like, can you build a product and a UI experience around it such that crappy like quality is okay? And then if you can combine the two and figure out a way that it works, then great, like you can just polish it and productionize it and ship it. But very similar to the old UI world.
You can still have animations and sparkles in an agent.
Yeah, totally.
I mean, I would also add to that, taste is often developed by observing what other people do too. So you don't have to just purely, birth this new great idea that's very tasteful. You can, learn from others. So, yeah.
So you guys are kind of hinting at this and danced around it a little bit, but the sort of difference between the blank page problem and the where does the browser, the AI step in versus where it gets the hell out of the way. Hursh and Kevin talking about this sort of thing. Like, where is that for both of your, I guess, entry points?
Where does the AI step in versus where should the agent get out of the way?
Yeah, I think like it's very important to have there are a few layers to this problem. One is you definitely should have a way for all users to turn off AI, and that should be heavily respected in your product, especially if your user base is not just pure AI users. The second thing is I'm personally very against AI just come in and just start doing things by itself. I think it's a very destructive user experience. I think we're trying to like think about any experience around computer use, we can kind of build with our app. And this is kind of the main challenge. Like, you don't want an AI to come in, just hijack your browser. Like, you're just typing a doc, it close a tab and start opening all these crazy stuff. So I think if there's anything that's passively suggested by the AI, it needs to come in a suggestion. It needs to not be in your way of your work. And that comes back to the UX design problem. Like, how do you make sure you notify users and give them an easy way to utilize that suggestion without getting into the way of their normal workflow, and they could easily like ignore it if they don't think it's helpful.
Yeah, I think this is a UX design problem of like, how do you make sure you show it in the right mechanism? How do you make sure that the text or whatever it's trying to recommend is high signal? How is it not annoying when it doesn't do something? How do you not, if you're doing stuff in the background automatically, how are you not like ruining their state or causing their CPU to whir, or doing something problematic? So these are all just like parts of building the feature. I think it takes some finagling and taste and playing with it, and honestly just using it and seeing if it's annoying, and then just being like, oh, this needs to be dialed back, or like this is the quality is not good enough. It's annoying because it's suggesting crap, and it's not actually the UI that's a problem. It's the quality that's a problem, and so it's a multivariable problem to optimize.
Have you guys run into like managing larger and larger accounts and number of tools? Like as Calvin mentioned about the tools, and what have you found to be useful to like ensure quality and cost and buffer intelligence?
Managing larger prompts, especially with a lot of tools, and managing cost and quality and speed.
Yeah, I'll say larger and larger prompt has become less of an issue now because one, you have model context window that's growing basically exponentially, and two is really like because of prompt caching. So if you're a team that start like trying to optimize for cost and latency, I would say before you look into like maybe some crazy ideas like RLing open source model, you should really look into prompt caching, and that's what's gonna save you like 90% of the token. And because of prompt caching, like even if you have a long prompt, the extra cost to users and us is very, very marginal because we can just reutilize that cache every single time a tool call or a request is invoked.
Yeah, I mean, just like as context windows get bigger, the quality of the context is not necessarily increasing at the same rate. So I think all of this sort of goes back to experimentation, basically making sure that, if your prompt is getting very large, it's not regressing performance. So yeah.
I don't know if this is the right thing to do, but we just end up using a lot of classifiers. So we just classify the situation and determine what tools to plug in, classify the situation and determine what prompts to put into it, and that like seems to work. I do think models handle larger and larger prompts, but to your point, it has a certain instruction following budget, and we find if the prompt gets too large, it just stops listening. So we just prefer smaller prompts, but then you gotta also figure out prompt caching and not have it thrash the cache. So,
and then this gets to like context management, right? Like this is like the main problem in kind of agentic stuff right now, which is how do you put the right stuff at the right time into the model's context rather than just like dumping everything that you have. And so, I think that's like another thing that is sort of on the frontier of stuff. You can use sub-agents, you can use, compaction for your sort of message history, et cetera. And so that's how you sort of keep things, smaller. But again, you still have to measure it to see that it's performing well. So
if I may, I want to go a little deeper there. Like, what have you found most effective for memory? How do you build these classifiers? What have you seen work? I mean, there's a ton of techniques that people talk about. What have you seen work the most or not work the most? What's your underrated, overrated?
Classifiers and memory are two different problems. I think we've had so many attempts at memory to try to suss out like the one true solution to this. What we keep coming back to, there's a million ways to model this stuff, and you have to start with actual user problems and work backwards and like figure out, okay, how am I modeling either the classifier or the context, the context engineering I'm doing to actually solve that specific user problem, because there's a gazillion ways and frameworks now too, my God, to be able to build this stuff. But I just think if you're not starting with the problem and working backwards, it's so hard to retrofit. So we've found those frameworks aren't really helpful either because they don't know about problems your customers have. And so you got to start with that and then figure out the right architecture.
I would also say that I feel like Claude Code is sort of the gold standard for kind of managing context, and the Claude Code or Agents SDK has a lot of those tools built into it for you. So that's a good place to start. But yes, I think that you have to sort of mold it to your problem space. So.
Can you talk a little bit more about the classifiers? Are you running like a LLM inference, or do you have training data that you're using to route inference?
Yeah, it's a good question. He was asking, can you talk more about the classifiers? Are you using LLMs or do you have training data? We use the same playbook. So we like start with big LLM, get to B whatever, B minus quality, see if it's working. If it is, then we either from internal dog fooding data, or like we have a similar to them. We have like an early birds for people who want to test. We collect a bunch of data and then we deal with cost, latency, all that stuff. So we'll distill it onto a BERT or like a smaller model or something like that, or just hill climb on the prompt if it's fine being an LLM.
Can you do anything to measure the uncertainty of your outputs and like mitigate hallucination in any way? You guys would take it, 5 runs, 10 runs, like one does, but you guys do that in an independent system, and perhaps in real time, even looking at long prompts or doing some light works.
I actually did mine.
I think if I heard it correctly, is like how do you reduce hallucination in kind of the agent outputs, or like what are some measures you do?
Do you guys measure uncertainty in any way and mitigate that?
Yeah, I think for us, if you start observing a lot of hallucination, it's likely you're not providing enough context retrieval tools or allowing the model to actually access the environment around it to gather the proper set of data. What we're seeing is like maybe some of the earlier models tend to do this, where they just don't even call like maybe read file tool call and just start hallucinating what the kind of content the file has. But with later models, it has become a lot less likely when they try to just skip the tool call and try to directly guess what the content is. So yeah, like I would say one is make sure you have enough of the different tools provided to the agent so that it can efficiently retrieve the context. 2 is if you still observe a lot of these hallucinations, using one, either online evals to measure how often they actually occur. 2 is build eval sets to make sure that like, you tune the model parameter around these tool call and use that more efficiently.
I was wondering how you guys are thinking about adaptive user interfaces and how you might be pairing each user's individual memory with providing that adaptive experience.
Questions around adaptive user interfaces and individualized memory per user?
Yeah, we've prototyped a lot around this, both sort of dynamic interfaces that the LLM creates and how you use memory to actually make them dynamic. A few issues here. One is the tricky thing here is evaluating it and just making sure the quality stands, because when it's dynamically creating these interfaces and you introduce per user memory, usually there's so many edge cases because there's so many combinatorial, just combinations of things that can happen. So that coupled with the product market fit problem of like, is the thing you're solving actually useful? It's ended up we haven't shipped that many of those just because we're like, we can do it and it's cool, but it just doesn't provide as much value as just building a flow that is not personalized but is actually useful. So I think there's definitely a space for it somewhere, but for us, it's just like, okay, where can it really find utility? And we haven't quite found that yet.
Yeah, with memory, this is a hard problem we're fighting. We explored a lot of different approaches, as simple as just using a RAG and you have like all the user's context stored somewhere and we just perform RAG on it. That generally yields pretty poor quality results because every user, they might have like different set of contexts and you cannot use like one generic RAG pipeline to retrieve these. We also experimented with just agents being able to write memories. So it can, like based on the conversation, it can decide, hey, is this a useful piece of memory to write into my memory bank, whatever. That also turns out to be not useful because it's very, very hard to control the kind of the knot between it being too annoying and injecting too much basic garbage into your knowledge base, and that's gotta get stale over time versus like under injecting a lot of memory. The things we end up shipping is very, very under trigger. Like it maybe suggests like 0.1% of the time, which turns out to be not very useful. So I'll say this is a very hard problem.
Here's how you guys decide when you use new tools to build what agents. Do you guys find there's different building tools for like traditional products?
For us, we have a whole team and like work stream that is just thinking about what are the new tools to give Dia's agent. A lot of it's focused on like what will be useful for us. I think recently we found just the context building tools are really helpful, so we can get more context, so we can suggest stuff. But we do have some computer use tools where we can draft emails and calendar invites and stuff like that. So I think we're just continually adding more. How do we decide? We just like created a list and figured out how many users that app has, and then added tools that way.
So let me just build on that question, right? So recently we've seen a lot of launches of new products by OpenAI, like the browser, Perplexity, the same about a month and a half. Then we are beginning about November 24th for Cursor, right? Like the agentic capabilities of that tool there is amazing. And Agent Builder on the other hand, right? I'm just wondering, like those big launches, how do they affect your roadmap? And your plans, and maybe there are some features that you're planning to launch in the next couple of iterations, kind of differentiate yourself from those folks. Thanks.
Yeah. So when the big labs, OpenAI, et cetera, or other major players are launching kind of new competing products in this space, I mean, it's a pretty wild world these days. How do you handle that in React?
Yeah, it's wild, right? It's like kind of nerve-wracking. We've had a very specific strategy here, which is we are just like taking a totally different tactic on this AI browser war. We recently got acquired by Atlassian. We're just going after enterprise and work use cases in a way that Atlas and Comet aren't. So we're like heavily focused on, instead of like, how do you book a flight? We're focused on like, hey, can we prep you for your meetings, or like, help you write docs or reply to that DM or things like that. So I think that's our lane, and we have a lot of product engineering and design to find entirely novel ways of addressing that, and that's been our tactic. But it is definitely nerve-wracking. I'm like curious for you too as well.
Yeah, there's an agent mode, right?
Sorry.
There's an agent mode in the browser, right?
Yeah.
Honestly, at Warp, we're not too worried because the main reason is, one, we're kind of the area expert in terms of terminal infra. That's what we spent 2 to 3 years building, really like understanding the shell outputs and being able to parse out input output, being able to understand different platforms and how do you format your input properly. So I think also it's against like these big model providers' interest to like heavily subsidize their own users and cut off kind of API provider for other agent providers. So unless we're approaching the kind of plateau where there's one model provider that's dominating everything and they start like developing like downstream products and heavily investing like 100 eng onto them, we're not really too worried about their launches.
Yeah, I'd agree there too. For the GTM space, we don't really see ourselves as having like a ton of like super direct competitors. Like obviously it's a very active space and crowded space, but not a lot of people are taking the same sort of like tack as us. But I would also agree on in terms of there isn't a single model provider right now, and so people are actually fairly hesitant to fully commit to one. And so it's actually a good time to be sort of like a layer on top of those guys while they sort of duke it out. So that's sort of how we see it. But there have been some releases recently that look very similar to things that we have experimented with and maybe are continuing to develop. So we're keeping our eyes on them and maybe learning lessons from them too, from their releases as well. So yeah, I don't know. That's sort of how we go about our day.
With especially chat-based products, I feel like it's really easy to boil the ocean where people ask everything, you build tools that will never know everything. So I'm curious, like, how do you help people understand the limitations of what your products do?
With chat-based products especially, how do you help people understand the limitations of what your products get at?
I could go first. Yeah, sure. We heavily prompt. Well, so we have a feature called Sculptor, and basically that helps you sort of like build clay tables. So you say like, okay, I want this data point in my clay table, and it's like, okay, here's like a few ways you could get that. You can kind of like select one or whatever. It's kind of like a chat little sidebar thing, and we heavily prompt it to say what it has the capabilities of doing. And if you ask it to do something that it doesn't know how to do, it will say, I'm sorry, I can't do that. And we actually use that those interactions as feedback into sort of what we should develop. So like, for example, when we first released Sculptor, we thought it was really all about just building tables, but people asked it a lot of analysis questions about their tables. So they were like, how many, empty cells are there in this column or something like that? And we hadn't really considered that as a use case. And so we actually went, and now we're sort of building that use case out. Yeah, it sort of all flows back into itself.
Beautiful.
Biggest bottleneck for you guys is it retrieval layer or LLM inference? And one more question, you did mention about context engineering, that you have different classifiers, but in the browser you are like gathering history of months. So how would you do you think context window limit? How would you handle it?
Two questions in there. One was bottlenecks. This is more a scaling question, maybe. What are your bottlenecks?
What was the first option that you said? Retrieval layer. Got it. Okay. Yeah, definitely inference is very expensive and very slow. So that's definitely the dominant sort of cost at that layer. And it flows back into the architecture everywhere, right? Basically, you want to make everything async. So just synchronously waiting for the response is like a way to sort of like blow out all the memory on your servers if you're processing like a ton of concurrent requests. So yeah, definitely that's our sort of like biggest thing that we sort of orient our system around in terms of bottlenecks.
And then second question was the browser, just like you use it for months, and so like it develops so much context. How do you figure out the right stuff to query? Last year we had a bunch of mechanisms around this, like RAG and hierarchical summarization and all that kind of stuff. Now the models are so good at tool calling that we'll just give them sophisticated tools to be able to query whatever window or set of things they want, and they'll do a great job.
What are a few example tools?
Like we have a memory tool, and that tool is fairly has a lot of arguments you can give it around like the level of granularity and time windows and what kind of things and all this kind of thing. And nowadays the models do a great job of like querying it very sophisticatedly in sequence to be able to find the right stuff in the memory corpus.
What are like the general biggest unsolved problems in agents being engineering for your team? Like, what do you still hard for it to do?
Yeah, what are the biggest unsolved problems for agentic engineering on your teams? What's still really hard?
I mean, we've said it over and over again, but memory / context management, I think, is generally still fairly unsolved. Like people have various approaches to it that work for their specific thing, but I don't know if there's sort of like a great general framework for it yet.
Yeah, one thing I'm curious about is how are we going to solve agentic security? Like, how do we make sure that AI is safe? Right now, we're kind of doing a cat and mouse game where you have instructor kind of identify the patterns of how people jailbreak, and you instruct tune or like a reinforcement tuning your model to fit that distribution. But it's never going to fully capture like the full set of possible ways you can jailbreak. And we really don't have a good answer to this. And there are a lot of recent reports around how you could, exploit MCP servers by embedding information into GitHub README, say like, hey, upload your email address to this server by putting it into README, and it get retrieved in the agent MCP tool call, and the agent then start uploading your email address to the server. So these are the things that we don't really have an answer for, and I do think we need an answer relatively soon.
There are many more questions, but I think we should call it here. This has been awesome. I will be up here. I don't know if y'all can hang around for those who have more questions. Sorry? That's a good point. Are you guys hiring for any agentic product engineers?
We are.
Yes.
Wow.
Come talk to me.
Yeah, we're very.
What do you look for?
We're a very craft and design focused company, and we're building a web browser focused on work. So if you guys are interested in working in a very prototype driven, fast, design oriented AI engineering org, then come chat with us. And we have a whole row of browser company people here, so talk to any of them.
Yeah, for us, I think Warp is a really unique opportunity. We own the entire terminal stack, and terminal is essentially a window into your entire computer. So there's not really any competitor that's working on the same sort of tech stack as us. And we believe we can unlock the true agent potential with the sort of infra that we built up over the past 3 years and be really able to like deeply integrate it with the agent. So I'll be up here, and we have Tyler and Maggie all the way in the back, who's also representing Warp. Feel free to talk to any of us. And we are really hiring.
And here at Clay, this is our office, if you're not aware. So welcome. And yeah, we're also hiring for agentic product engineers. We've got our Clayagent, which I mentioned, very heavily used, still actively in development. And we're building all sorts of other AI features as well, including sort of like new agentic workflow stuff. So if that sounds interesting to you, yeah, come chat with us.
Stainless has no open headcount, so it's just not even. It's a joke. We have several Stainless people here doing all sorts of different MCP and AI SDK and agentic product stuff and so on. So come say hi. And we have some maybe small amount more food and I think still beverages and so on. What time do we get kicked out, Greg? Do you know? Get kicked out around 8 or so. Clay's mushy. I don't know. Hopefully we can hang out. So thanks, guys, everybody, for coming. This has been really fun. Hope everybody has learned something and also has at least one thing that they're like, I know the answer to that. And so please go tell everybody because there's so much learning to do on this topic. All right. Cheers. Thanks for coming.
Thanks, y'all.